we forgot. Thank you. But it's not so important, this part. I mean, the next one is the one that is important. So for anybody who is starting to see this recorded, we just forgot to record the first part, but it's not so important. Just stay with us from now. Okay, so everything is digital. So of course, people, as soon as they were able, started to use computers to do everything. And GIS is the keyword for us because it stands for Geographical Information Systems, and are software basically that can be used to handle, to manage, transform the geographical information. And of course, you end up with a product, the geological map or whatever cartography you are building, which is totally similar to what you could have been doing by hand. But at the same time, you have a data set, which is quite important, and you can share your data set with the other researchers, for example, and you can archive it so that in the future people can go back to your data set, use it again, do science on that, or derive new products. So just 2 words on that. There are quite different reasons why people might start doing mapping. So there are, of course, some kind of systematic mapping. As you might know, maybe your country is also investing some money in having a systematic program to create geological maps of Earth. And nowadays, USGS possibly is the only one that has a systematic program to map planetary bodies. And of course, when you have a specific mission, you might end up, one of the first things that we should be doing in a new mission is start mapping right away, especially if it's a body that we don't know, like a comet, an asteroid. The first thing is capturing images and having scientists starting mapping right away. And the kind of maps will be kind of restricted to that specific mission, but is of course the first thing that is important to do in such circumstances. So then there is, of course, other reason to create geological maps, and might be tied to scientific research or specific topics, for example. And the kind of map that might come out in that condition might be even different, and might try to highlight specific, let's say, topics, specific morphologies, or specific views of that planetary body we are mapping. And of course, they can be local, so a small region, maybe because we already decided where to land, for example, and we want to know very well what is happening there, whether there are boulders, whether it's a flat region or not, what kind of different rocks we expect to find there, etc. And of course, they can be of different scales. So this is an example of a systematic mapping of Ceres after the Dawn mission, and you see you try to complete the whole body with different map sheets, but it's a very systematic approach which is done as soon as the data are available during the mission. And of course, if you have different interests, like in this case, the Jezero crater, which was mapped, of course, for landing purposes, you might end up mapping a very restricted in high resolution region, and those are other examples. So go back to GIS. It stands for Geographic Information System. It's a software. There are many different softwares. Here we put together some which are open source. Of course, ArcGIS, which you might know is not open source, is proprietary. But of course, if you are approaching mapping, you're doing your thesis in university, for example, you might be more familiar with that. What I would like to say here is that whatever GIS you start using, whatever GIS you know, most of the terminology, most of the concepts going on are basically the same. So it's not so difficult to move from one to another as soon as you try to organize what you know in some concepts. So there are basically two data models which are used in GIS software, and this is kind of intuitive representation. So you have on one side vector data and on the other side raster data. Raster, we will see more in the details in the next slides, but I believe this is mostly intuitive, and it really depends what you are doing. It really depends what kind of information you are trying to represent in your software. Raster data are basically images. Of course, you know that an image, if you zoom in into an image, you end up seeing the pixels of that image. So this means that basically a raster image, or anyway, an image is just a matrix of values which are organized like so. For example, the typical use of this kind of information is on one side, for example, to classify a large area. For example, in this central image, you see, which is just an example, you see different classes classifying land use. So you might either have agriculture, you might have mountains or stuff like that. On the other side, raster data are used also for encoding topography. So a typical use is the DTM, which you can see it at the right. Again, an intuitive representation. If you have a surface like this one, which represent your elevation model, you can encode that like an image where each pixel has a value, and that value might correspond to your elevation. So those are the typical uses for raster data. And more importantly, because we are going to play a lot with those vector data. Typically, they can be points, lines, or polygons, but the idea here is that for any kind of feature that you can mark precisely, like a boundary between two different regions, like a specific point, or like a specific area which is bounded again by a line, you might want to use vector data. This is because you will encode your data as a list of points that are then, for example, connected. They might be standalone, so just points, like in this case, like here in this example, they marked up the wells like points, or you can draw your rivers, for example, as lines, and in this case, they drew a lake like a polygon. One important thing about that is that at the end, you can also store additional information. So, for example, each of those wells might have a name by which people refer to that specific location. So we might want to store that information together with the point. The same is true for the lines. So, for example, a river might have an associated name, and you might want to store that one as well together with the geometry defining it. So there has been quite some evolution in the years of different formats, different ways of doing this specific task. And we will see how to create vectors later. As you know, planetary bodies can be approximated, are normally approximated like spheroid or ellipsoids. Typically, they aren't perfect spheres, so we need, we call it an approximation, of course. And the real shape of a planetary body is called geoid, while the approximation is normally done with a spheroid and an ellipsoid, like in this case. This is quite important because together with another information, which is the map projection, we are gonna use this kind of definition later in QGIS. Then, of course, you know that planetary bodies are spheres, but whenever we are working in the either on a paper where we are tracing our map or in a GIS software, we need to transform that three-dimensional information into something that is flat. To do so, we use map projections. There are quite a lot of them, and here you see just some example to give you an intuitive idea of what happens. So, for example, you have a cylindrical projection. You wrap the spherical body with a cylinder, then you project all the information on top of the cylinder, and you might end up with something like this. I told you those two words, so ellipsoidal approximation, so the ellipsoid and map projection, because together they build up what is known as CRS, Coordinate Reference System. There are quite some different words of saying that, but we will need to have a basic understanding of what is going on later on QGIS. So a CRS is a way of standardizing, of giving, let's say, a name or at least the parameters of a coordinate reference system. Yeah, that's not really clear, but anyway, a given CRS defines the ellipsoids that are used, the ellipsoid which is used as an approximation, and then it also defines the projection that is used to transform the ellipsoid to a three-dimensional space, so kind of Cartesian coordinates. There are quite different additional parameters that are needed that you should be specifying to be actually very precise in defining your CRS. And you see here three examples. So this is a standard, the approach for standard to express CRS. You can find it within QGIS. It's quite often used. And you see how it is spelled out, like you have a projection, you have the radius of the sphere that you are using, you have also the units you will end up after projecting your data in 3D. And this is another example. You have a different projection, you have a different radius. In this case, you also have what is called the reverse flattening of the ellipsoid. So this means that in this approximation, we are going to use an ellipsoid. In that one, before we were using a sphere. There would be quite a lot to say on that, but that's all you really need to start using QGIS, I believe. This is just to clarify some points that, okay, of course, we start from something that is a sphere, a body which is round. Most of the times, that might not be true for some minor bodies, small bodies, and you end up with something like this. Depending on the CRS and the projection in particular you are using, you might end up with something quite different. So you see this kind of projection is equirectangular because you see that you have little squares where which are mapped to the squares on the sphere. This is another kind of projection, the Mercator one. And what I would like to show you is that distances are not quite respected in some projection, which is quite relevant for geologists, especially if you will try, for example, to measure, I don't know, the size of a crater, and you are taking the same measure at the equator, then you move, for example, north towards the North Pole, and you take the measure of a different crater. You should be quite aware that depending on what you're doing exactly, there might be some issues. So, for example, you see that distance in yellow up there and the distance in red over the equator, on the flat version of the world, they look basically the same. And you see also this green line connecting the two, and you see that the length of this line and the angle on the map of this line, it looks quite different. So every projection will also introduce some distortions, and they can be in the distances, in the angles, or in the areas represented. And basically, it really depends on your interest. So if you are interested in computing areas, you might need to choose a representation, a projection, which is preserving for you the areas, and the same for distances, etc. Last days with Riccardo, we noticed that QGIS sometimes with planetary projection kind of act funny, especially on measuring the distances. That's not a big problem for the school, but of course, be aware if you start doing your mapping, if you start to doing a research using data, take your time to fully understand these kind of problems. Because of course, if you are going to measure orientation, measure angles, measure sizes of the objects on the planetary body, especially if you then want to compare them with the same features, for example, nearby the North Pole or in the South Pole, with features that you have taken, for example, on the equator, that might be a problem. So take your time to see that in details. So we have here, I will take just 2 minutes to tell you what we are going to do here. The presentation is over. Hope the next couple of hours, I guess, will be kind of funny for you if you share with us our, let's say, passion for using computer software and data management and stuff like that. I believe it might be even be funny. But we really need you to get the basics, so each one of you will be on the same page for the next days in QGIS. We don't want you to spend time during the practicals mapping in solving problems related to QGIS. Of course, we will be there to help you if you need, but if you take your time now to try to fully understand what is going on, then it will be more time for you learning geology and mapping and not really learning QGIS. So I will try to follow this kind of sequence. I will show you in the presentation. There are quite a couple of slides more. One with the links, and one with just an interface of QGIS and some naming. But we are gonna see it live over in QGIS. Riccardo will be here to help highlight stuff while I'm talking, probably. So hope that helped. And anyway, let's have a quick look at the program. So we are basically in this session. So in this session, I will start showing you some stuff in QGIS. Then Riccardo will talk about QGIS again, showing you possibly again more or less the same stuff, but he will try to go more in deep. And then what is really important, because I can imagine some of you already know perfectly QGIS, so feel free to just, I don't know, listen to music or whatever. But what is important is that in this session, we will do a demonstration of a plugin we did basically for the school. And that will be pretty important because the practicals will base mostly everything on using that plugin. So be sure to be here. At the very end, after Trent will present some other stuff on QGIS in this invited talk, we will have a kind of really open session where you can bring your beer if you want. We will try to be there for you. So it's time for you to actually try it out, do it everything again from scratch. So if you need anything, it's a good moment to ask, so that the next day you will be up and running in no time with your QGIS. So let's start. I will show you. I will close this presentation. We are not gonna use anymore. So this is the outline, the same you can find in the presentation, just a little more readable. And I will try while we go ahead to tell you where we are. So especially if you are gonna come back to the recordings of this session, you might have some ideas where we are. So first of all, the interface, QGIS, panels, toolbars, etc. So let's fire up QGIS. I know that might be difficult for you to both follow the Zoom room and also try to do that. We're gonna do our best. So open up QGIS, everybody, and if you get totally lost, if you want me to show you something again, try to write down in chat. Riccardo is also here, and we will try to do our best. So first of all, this is the interface of QGIS. I would like to, just as a personal interest, to know if you could write down in the chat whether somebody was not totally notable, just so we can have an idea whether somebody was totally notable. So Riccardo maybe can take a note of that. So as many applications you already know, we have a top menu. There are quite different options here. We will have a look at it more in detail later. We have the toolbars, so what is called, Riccardo, are you here? Rick?
Yes, I am. Yeah, sorry.
Yeah, thank you. Could you help me highlighting some stuff for them? Okay, thank you, Rick. So those are the toolbars. There are many of them. You can see you can move them around. So for example, this is possibly the most important toolbar where you can save and load your project. You can take them, move them around like so. For example, decide where you want to place them. You can place it in totally different places. So don't worry if your QGIS doesn't look exactly like mine. You can modify the interface. You can move everything around. You can arrange stuff in the way you like. Next, the panels. So you see that you have this kind of different panels. You can also detach from the main application if you have, different monitors, an additional monitor, you want to move it in a different place. You can stack them one on top of each other, for example, and you can go back and forth between them. You see they look like tabs, and you can choose which one to show. I would try to keep them as they come, if I'm able to. Yeah, layer, I keep the layer on top, or maybe the layers on the bottom, like it can when you start the first time QGIS. You have another set of panels, like so, same stuff. You can move them around, you can arrange them as you want. And in the very center, now you see your news. You can find some news about QGIS, but you also see project templates. We click on that, we start an empty project. So we basically have this section here, which I would call the canvas. So it's like where we are gonna draw everything and actually do our work. Let's go through a little bit on the menu. I believe you can readily understand what is going on. What I just wanted to tell you is that basically each button you see here, at least most of them, they also have an entry in the menu. But let's say that not all the entries you can find in the menu are also on the toolbar. This is quite common because, of course, the most used tools are exposed as a toolbar. but some of them which are related, for example, with option or stuff like that, maybe you cannot find them in the toolbars. Okay, so there are quite obvious. Some of them are quite obvious. Try to play with them. That's not a big problem. Even if you end up in something that you don't know what to do, just close QGIS and start it again. We will, of course, use a lot this menu layer, but possibly we will also use other, let's say, the commands from the toolbars actually. Also, you can find the settings, plugins. Riccardo will show something about the plugins, how to load new plugins. And then, of course, you have the processing. So you have tools for processing vector data, tools for processing the raster data, and then also databases, which are kind of a big part nowadays of GIS, but we are not going to go in that actually. This menu here, the processing one, might be helpful because you see the first entry is toolbox. And if I click on that, you see that this panel disappear or it appear again, like so. So you can use that. And as I said, there are kind of possibly 2, 3, 4 different ways of doing the same thing. I will show you, for example, if I want the processing toolbox to appear, I can click here, it appear, and then as Riccardo is highlighting here, I can click on that and the toolbox will go away. But it is basically the same command whether I can click here. You can also see the shortcuts. So if you want to be a little bit faster, you can use them. And you can enable and disable, for example, this panel. The same thing can be done in a third way, which is by right-clicking on an empty space on the toolbar, like so. And you see you have this kind of dialog with panels, and toolbars. We might need to use them. So for example, I'm looking to disable the processing toolbox. I can go here, I see the processing toolbox is active, I can disable it. And then I can enable using either the button on the toolbar or the menu entry for the toolbox. This might look quite redundant, but of course, if you are starting out with QGIS, you might want to go in the menu and see, because you can actually read the description. If you hover, normally you might get something more, not in my case. But anyway, you can use the menu if you kind of forgot what to do. So for example, later we will create layers. And of course, if you forgot how to do, you can guess. The layer menu might be helpful, and you can go under create layer, right? So if you forget about that, it's a way of solving your problem. At the same time, there are also this toolbar, which is called Data Source Manager Toolbar. I can use that to create, for example, a new GeoPackage layer, exactly like I can find here, new GeoPackage layer. So a lot of different ways of doing the same thing. Keep in mind that next days during the practicals, also the instructor, in some cases, they come, for example, from ArcGIS, they are used to that. So you might see that what I'm going to show you here, it might be different, but it's nice. So you have a way to see how different people approach it. So let's go ahead, go back to the overview here. We will basically create a little mapping project by importing the data sets. I hope everyone here downloaded them. Mine are somewhere here. So let's see. Mine are in this folder, QGIS demo. Basically, if you downloaded it, you have to unzip them. You end up with this folder. Into this folder, I also placed my presentation actually, possibly you don't have them, but anyway, we are interested in the raster folder, and here we can find 2 different images. One is a DTM and the other one is an optical image. To load them, again, there are quite 200 different ways to do that. You can use the menu. If, for example, you forgot how to do that, you can go over layer, then you can guess that it's add layer, and then possibly guess that is add raster layer because they are images. If you want to be faster, you can just drag and drop them. Let's see whether it works. And bring them into the canvas. So you see what happened here? We now have two different layers. This panel here is showing you the different layers that are being loaded in QGIS. And basically, it works like Photoshop or something like that. You have different layers. You can put them one on top of each other. You can put them on top of each other. And let's see what was in the list so we can follow along. What I want to use, well, mouse buttons, they are quite obvious. You can basically enable, disable stuff with your left click, the left button. Of course, if you have a wheel on your mouse, you can zoom in. To pan, it's left click and then drag. Quite common, like in many software. So just try to look around, move around, enable, disable the layers. Of course, you can reorder the layers, so I can change the order, just dragging this one on top. So I see now this one is on top and the other one is below. One thing you can do, so we have two images. The first one is basically, yes, Riccardo, there are also some tools here. Of course, as I said, you can do the same stuff in many different ways. You can click it to enable panning, or there are quite some useful tools to, let's say, zoom to the layer, zoom to the, so for example, if I get lost, totally lost, I don't see anything here, by right clicking with your mouse here. So I go over a layer, right click, and this menu opens up, and you can go over zoom to layer. Something I forgot. Not transformable. Yeah.
In the chat, there are a few questions that maybe you can address.
Yeah, I saw them. Yeah, thank you.
There's this question about coordinates. The error that many people are having is no transform available between sinusoidal Mars and custom CRS.
Yeah.
If you can address that.
Yeah, I will show you that. I will show you that if I close my QGIS again, I open it again very quickly. I will show you what happens. That's basically the next point. If I import the data here, you see this kind of error that come up. No transform available between sinusoidal Mars, custom CRS. Well, I don't have an exact explanation for that. We believe that at the very beginning, whenever you start QGIS, it starts with a projection, a CRS system, which is one for Earth. And as soon as you import some data, if they are the first data that you import, it will change the project size CRS to match that data. But I guess that doing so, this kind of error come out because you see that the error is reporting that there is no transform available between sinusoidal Mars, which of course is a CRS for the Mars planetary body, and another CRS that here I can see is defined as ellipsoid WGS 84, which is an ellipsoid used for Earth. So, end of the long story short, don't be worried. Be aware, always have a look at the errors. Sometimes it's just to, I don't know how to say it, they keeps coming out, these kind of errors. That's not a big problem, especially now where we are just doing an exercise.
Sometimes it's just telling you that the CRS has changed with respect to the default. But if you click down in the bottom right, where I have put the square, you would see that it says unknown CRS. but you see that he actually recognizes it. The problem is that it doesn't have it into its database. And so it doesn't know how to call it. And it's not, let's say, one of its default. So it's telling you, hey, look, there is something weird happening. But if you look closely here, everything is fine. And so it's just telling you, I am shifting the reference system. Please check, because by default, I am set for Earth reference system. So it's an error that comes up every time you load a new file. Of course, if you continue to load files with the same CRS, then it's okay. But the first time it changes it. And if you click there, you will see. And it's just telling you, hey, careful. But it's okay. It's not affecting anything you will do later on. Okay. And the latest version, of course, is QGIS 3.22.3. But from 3.16 on, we are able to work fine with that.
Okay, thank you, Rick. We will come back on the CRS thing. I would like to try to follow this. I would like to show you that you can apply different styling to your layer. So what I've loaded here is a raster file containing, basically it's a DTM, where each pixel is containing the elevation of the surface at that point. As you see here, just below the layer, we have two different values, which are the minimum and maximum elevation. So in that case, this is on Mars. We have -3 kilometers to -4.6 kilometers, something like that. So it is not a classical image. It is not an optical image, but rather is a data set containing elevation information, one for each pixel. And what we can do, as you can imagine, right click, you open up this dialog, and you see there is the last entry is properties. So if we click on properties, we have kind of a lot of different information. Like, for example, the CRS, it tells us is sinusoidal Mars. And we got a lot of statistics, the sizes, etc., etc. I just want to show you that, for example, if you go under symbology, there is several options like band rendering, color rendering, resampling. Play with those. So, for example, color rendering is quite similar to Photoshop or whatever photo editing software you might have been using. So you can change contrast, change saturation. Every time you change something, you need to press apply to see the effects. So, for example, I can change from single band gray to single band pseudo color. So we can put on that some colors. You see that QGIS already computes different colors for different elevation ranges. You can play with that. You can change the color ramp. You can invert that. And just try to play with that. And just by pressing OK, you end up changing the colors that are used to display that information. And here you see the color scale. So you have the difference values. So you know that in this portion, we are around this value. And whenever it is light blue, we are mostly around this value. Another option, for example, there are, we will see them later, and also Riccardo will show them. So I really wanted to stay simple here. Let's load again the image just for you. Another option might be that one, that transparency. So, for example, I can change the transparency to see below my image. Or, for example, I can use color rendering here. Again, I will repeat, right click, properties, symbology. We are now set up to be single band pseudo color. And what we can do, for example, is change the blending mode to overlay. And I'll go back. I set up again transparency to opacity to 100. And with this setup, if I click on apply, you see that the effect is very nice, interesting. So we have the grayscale image below, which is then colored with the colors we are using. So if you have been playing with Photoshop or something like that, you might understand that you have, for each layer, you can set up a different mode of blending and you end up with different results. So back again to this, we are at this point, we want to, again, very briefly, we already said something about that. What I want to show you is that each layer has a specific CRS. So for example, if I go here over layer CRS or set layer CRS, so again, right click, layer CRS, set layer CRS, you can find that this layer has been set up to be sinusoidal Mars. And the full definition of the CRS, there are two ways of defining it. One is WKT, which is not really understandable, at least to me. The other one is Proj 4, kind of more understandable. So you have the projection, you have the zero longitude that we are using, the radius of the sphere that we are using in the units of measure. And not only each layer must have a CRS. So if you import some stuff, which is random stuff from the internet, you need to know which CRS they are using. And we also have what is the project CRS. You can open it up from this bar on the bottom. If you click here, you end up with this dialog, which is called project properties. And under CRS, there is project CRS. So the CRS that will be used in the canvas to display whatever you're doing. So they both match, basically, this one and that one, because the first time we imported the layer, QGIS saw a different CRS and then modified the project CRS to match the one in the data. I see there is a question. When I try to change the elevation profile to false colors, the level disappears. Oh, maybe there is an answer. If you cannot solve it, maybe later we will have time to see that. So, okay, CRS. They are quite important.
For these technical questions, we have a channel in Discord. It's called GIS Help Desk. And you can write them there. We can solve them.
Yeah, I mean, anyway, later in the evening, there will be plenty of time to play, and we will try to get all the questions and all the whatever troubles you might be into. Let's go back. Let's go back here. Distances. And I just want you to show there is this tool here. This one, I just try to show you where I am on the toolbar, which is made to measure distances. And as you see, you have Cartesian distances and ellipsoidal distances. In this case, just use Cartesian, and I will show you why. And if I, this example, I want to know the diameter of this crater, I can click, and it will give me a measure around 13 kilometers. You can do it again. And of course, you can go ahead if I want to know, I don't know, the length of this channel, I can take the measure. If you move to ellipsoidal, you see the numbers goes crazy, and we don't have exactly the explanation, just don't do it. We will need actually to dig deeper into that, but at least in this case, with this specific CRS, QGIS is going crazy, so it's not working. Just use Cartesian for this example. But of course, if you are doing your research with this, take your time to solve this issue and understand perfectly what is going on, because we also don't know exactly what's happening. We have some ideas, but we quite didn't have the time to try to fully solve it. So you can try it. And let's see where we are, measuring distances, and now we are ready to start creating some vector layers. So the layer we have been loading are raster data. Now let's see what happens with vector layers. I will not give you much explanation, just try to create them. Of course, pretending I don't remember where the tool for creating vector layers is. Just go on the menu, find layer, might be layer, create layer. So it makes a lot of sense. You can try different kind of layers. I would like to suggest to use GeoPackage because they will be used later during the practicals. What GeoPackage is a kind of database. So it's just one file in which you can put any kind of different layers you want, or different vector layers. I guess there is also a kind of support for raster, but we never used that. So if you try it out, just try. And so new GeoPackage layer, it open up this kind of dialog. Ask us where to store the database. So for example, in my case, the data is over data QGIS demo. For example, I might want to call it, geo database, mapping, something like this. Press save. Okay, so this is the location of my database. So the GeoPackage, you see this extension, GPKG is the extension for GeoPackages. It asks you a table name. As I said, being a database, they use this kind of terminology, but what they mean is actually layer name. So just remember to change it, or you might end up overwriting over and over the same layer, losing stuff. So for example, the first kind of layer is a point layer. So because we will see how to draw some points, I will call it points. The geometry type, of course, if we want points, is point. And those options are not really interesting for us now. Just go below. You see that you have a CRS option here. There are some that you can find in this dialog. We will just select project CRS, sinusoidal Mars. And then we see here the new field entry, which is used to say which kind of information we want to attach to each point, right? So for example, as I say, maybe I'm tracing the position, I don't know, of some very small craters. So maybe an information I might want to add is crater name, right? It will be a text data. And if I'm happy with this setup, I can just press add to fields list, like so. For example, if I wanted to add, I don't know, diameter, right? I select decimal number, real number, and I can add to the fields. Or for example, I want to give them a progressive ID, different for each. I can possibly use integer, right? Like so. When I'm happy, just press OK. It will create the GeoPackage. And my GeoPackage, I created it here. So you see Geo database mapping, GeoPackage, and automatically it will also load up the layer we created here. So we have points layer here. So we'll give you just some seconds. So if you have created that, I will show you how to now add points. To do that, we need to, first of all, enable the editing for that specific layer. You can do that in many different ways. Again, one way is right-click with your mouse, right-click the right button, open this kind of context dialog, and you can find toggle editing, like so. And you see it changes the little icon here with this pencil. Riccardo is showing you that we also have toggle editing up there. So you can enable, disable, and you see the menu is actually not really the menu, the toolbar is changing. So the icons from grayed out, so disabled, they become colored, so they become enabled. So again, enable editing. Now we have the full toolbar, and the first command, the first tool we are going to use is this one, which is add point feature. So if you click on that, you see it stays selected. Now we can start adding new points. So for example, I zoom here. I will try to mark some very small crater like this one. And you see that as soon as I click, this kind of dialog will open up. And you see that all the fields we defined are here. So it will ask me whether I want to give a crater name. So maybe it's crater 1. Maybe I know the diameter, so I can say, well, it's, I don't know, 120, just guessing randomly. And maybe I want to give it a number, so maybe it's the number 1. I mean, any kind of information you might believe that in the future might be useful, better do that while you are mapping, right? Because if you have to fill all those kind of fields later, it's a lot of work. So 1 point over here. Let's just add some of them more. I will not fill this up just for being quicker. I will just click on some craters just to show you what happens. I don't see a point edit, only for polygons, because you created a polygons layers. We are gonna create it anyway, so keep it. But meanwhile, you go over layer, create layer, new GeoPackage layer. Just wait. We're gonna do it anyway. So just wait. You created the wrong kind of layer, but wait 1 minute. So this is how you add points. So given we had this question, I would like to disable editing, and you see what happens. Do you want to save the changes? Yes, of course I want to save. So remember to save, and the editing is now disabled. Now we will create different types of vector layers again. So you see how to do that again. Layer, create layer, new GeoPackage layer. What we are going to do here is not really create a new GeoPackage file, but we are going to add a layer to the already built GeoPackage file, right? So new GeoPackage layer, we need to select the database. So for example, Donato that was writing the chat will be doing this. Select the geodatabase mapping, again, the same file. You see my specific dialog looks like this. Ask me whether I want to override that. Just say that's okay, because we are gonna actually add a layer, not actually rewrite the file. So now what happens to Donato before is that where he selected possibly polygon here and not point, right? We selected point, we selected polygon, but we are gonna create 3 different layers, one for point, lines, and polygons anyway. So this time we are gonna create a line layer. Be careful here, select the right project CRS, or bad things will happen. Not really, but pay attention, and also pay attention to the table name. This time we are gonna call it, for example, lines, because we are putting lines in that. The kind of fields we might need, maybe, for example, I want to keep a note about the type of the line we are tracing, whether it's a fracture, is a fault, or maybe it's a contact, a boundary between 2 geological units or something like that. So type, we might want to keep text data, add to the fields. Or maybe another one, certainty. We might be stored the information whether we are totally sure or maybe a little bit unsure of what we are tracing there. So maybe it is another useful field. So add to the fields, check it again, job package, table name, lines, geometry, line, project CRS, right? The two fields that are listed here will be created. So one type of type text, and one called certainty, again, of type text. When we press over OK, you see this dialog, pay attention here. The file already exists. Do you want to overwrite the existing file with a new database or add a new layer to it? We want to add a new layer, right? Add a new layer. And now we also have the lines. Same thing in toggle editing. We enable the layer for the editing. We create a new line. You see, before we had different points. Now we have add line feature. And then, of course, we will also have add polygon feature. So we create a line. So lines are quite useful to represent anything that might be, of course, represented with lines. So, for example, the edges of those channels might be represented with lines. You see that, I'm not sure how much you see, but of course you can do it again, telling you which mouse button I'm pressing. So first click, it's left click. So I click, you see this dashed line, dotted line, whatever, come up, and it will follow my cursor everywhere. And I just need to decide where to put the second point. So again, left click, left click, left click. If I'm happy with the line, with not really the dotted line, but the solid one, I can right click now. So I do a right click, it will close the line for me. So you see, it's finished. And the future attributes, it's open. So for that line, it will ask me whether I want to set a type and a certainty for that line. So type maybe is channel edge, something like this. Maybe certainty is certain, right? So I click, and that's all. You created your line. I will do again a couple of times, like so. Right click, type, channel edge, and then certain, and okay. Or maybe I will use a line to trace this boundary here between different units very quickly. And this is maybe a contact this time, and the certainty is certain, or maybe it's approximate. Okay, so you create lines like so. At the end, disable editing. Do you want to save? Of course I want, right? So save your data. We can create now another layer. You already know how to do that. So create layer, geopackage, select the geodatabase mapping, or whatever you called it. Replace. You see now we will create polygons. So table name, polygons, geometry type, polygon, CRS, sinusoidal mass, the same of the project, fields, area name, for example, maybe another one, type, add to field list, okay. Pay attention here, not overwrite, add new layer. So now we have the polygons. So for example, we might use polygons to highlight this kind of, to map this kind of features, this kind of mesas. So again, enable editing. This time the tool is called Add Polygon Feature, surprise. We can click on that, left click, left click, left click, left, 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 left. When I'm happy with the polygon, right click. And again, future attributes. So you have area name, type. So for example, this is Mesa number 1, because it's the first one we mapped, and the type maybe is Mesa, right? So maybe the type, I will use type as a category, and maybe other fields just give some more information. Okay, we can map some more of them, like for example, this crater. Again, right click, area name is crater 1, type is crater, right? This is another Mesa. I will show you just briefly how to do that. Area name Mesa 2, for example. This is category Mesa, right? For example, here I will map this part of a channel like so. Right click, area name, channel 1. The category is channel this time. Okay. I believe that's quite simple. So points, polygons, and lines. We're going to use them. So let's go back here, what we are missing. So we have seen how to create them, right? The fields, how to create them, points, lines, polygons. Only later, Riccardo will show you how to edit them, because there are quite a lot of different tricks to do so. You can imagine that once creating them the first time is easy, but then if you need to change it, you need several tools to modify them. Let's see what we are missing. Add point, line, polygon, future, populate fields. We are there. Next step is the identify futures tool. I want to show you that. So we got this tool up here. Identify futures, you see that over there, right? If we click on that, and we have one of the layers selected, so for example, the polygons one, this one, I will disable editing because I don't care anymore. If we click on that identify future tool on the toolbar, then we can use it to click on top of different futures, and you see that, at least in my case, it will open up this dialog. It will open up this dialog, possibly not on yours, I will tell you now. But of course, we'll open up this panel, the identifier results panel. So over in this panel, you see the results of your identification, right? So let me show you. It will give you the position, a lot of derived properties, actually, like the area, etc. You see the area in ellipsoidal doesn't make any sense, possibly. And that's all. What I want to show you is here, under identify settings, you have an option that is auto open form for single future results. So what happened? I've got it enabled. If I disable, I can click on them and see the results, right? I click on the different features on that layer, and I can see the different results. If I click on a feature and then I go over there, you see the first icon is view future form. You can click on that and you see the fields that have been written down before. So I can choose a feature, open the dialog, and this is the dialog just for that feature. What happened, for example, if I enable editing, you see that now I can actually edit the fields. So for example, I was wrong. This is not crater 1, that is crater 10. I can add a 0 and press OK. Then if I click on that, you see the information changed. It's now crater 10, right? If I want that every time I click on a feature, the dialog opens automatically, I can click on that. And now it will be very easy to go over there. Let me close one. To go over there and change the value. So maybe this is not 1, maybe this is not Mesa number 1, it's Mesa 100. And you see all the dialogues remain open. This one maybe is Mesa 20. Okay, just play around with that to change some of the values. And that's all. Another way to change, I will disable editing. Of course, you need to save them whenever you did this kind of changes, even in the fields, not just in the geometry. So save. Another way of doing that is by right-clicking here. And there is an entry which is Open Attribute Table, which will open up for you this table, which is basically like on an Excel table, something like that. And you see here all the different values, right? So for example, this also works in this way, which might be interesting. Here, if I click on this number here, it will select the row and will show me which feature it is, right? So that one is this one. That's one, that one is another one, and this one, right? If I want, I can also edit the values. If I toggle editing, you see this is possibly the fourth way of enable editing. I click on that and I can change. Maybe this is not Mesa, but I changed the category. The category is called Mesas, so I can change it. Same like so, right? When I'm happy, I can save and disable editing. The same applies to lines, for example. Right click, open attribute table. You see it lights up. You can already see much of that, but it lights in yellow. You can select it. You can enable editing. Maybe I changed my mind. Maybe it is 1, 2 is approximate. And when I'm happy, I can save it, disable editing, and so forth. Let's see what is there. Styling vectors. Yeah. So we are basically here, attribute table. We go ahead, it's styling vector. Riccardo, if I need to go quicker, faster, just tell me because I don't see the time exactly.
We have 15 minutes left before trans seminar. So the advanced modifying tool, either we do it now or after the seminar.
Yeah, okay, we will move it if we can't. Okay, styling vectors. Of course, the nice thing is that you can apply different styles to this vector data we created, exactly like we did with the DTM. So you can already imagine how to do so. Right click, properties, and you have a symbology. Of course, the dialog is different, but you see again here, you have different options. One you might want to use is categorized. And you see here, it asks you for a value. You can set any of the fields we created. So for example, we want to give a different color to the different types of area we mapped, the different types of polygons. You set it, you press classify, and you see it will go through the different data. So for example, we have channels, we have craters, we have mesas. So as I press OK, you see the colors change it depending on the type. So for example, again, I edit a polygon, I want to add a new mesa. I need to write under type, mesas. Okay, it will become of the same color. We are at the end for now, and what the last thing is project saving. So whenever you are happy with the setup you end up with, you might need to save it. So project, save as, like in any other program. I don't know why my system won't open up. I got stuck. Here it is. Save the project. So for example, I'll go under QGIS demo, my mapping project. Save. And then we need to save once in a while. whenever we change some settings, it's important for you to understand that the project is not the same as the data. So whenever we were editing the data, we were using this button, which is Save Layer Edit, which is different from the project. If you save the project but not the data, you might end up losing something if you close the QGIS window in a bad way. So I guess that's all from my side. Yeah, just need to show you that the project for QGIS files, it is called like this, QGZ. So it's my mapping project. You also see that the size is so small, it won't contain any data. The data is either in the folder, in the raster folder with the 2 images, or in the geo package. So keep in mind, if you move around your data, you might end up with something, some projects that will not open up exactly because it cannot find your data. So keep them, let's say, in a structure of, or in a structured folder where maybe you have your project, and then you have different folders for raster data, for vector data, and so on. So now Riccardo can show you something more complex, right?
Second, I'll try to.
You have 10 minutes left.
I'm sorry, Riccardo, it took me quite so long.
No, it's okay. I mean, it's basically, now I will show how to modify and edit what Luca just created. Let me share my screen and just a second. Okay, I'll hide this.
I believe, Riccardo, at this point, we will move the practice with Mappy.
Yes, we moved the
Trent.
practice with Mappy.
Yeah, after Trent. I was too positive on the timing, so.
I think it's okay. So this is the mapping project Luca just created. I mean, a similar version, at least. Okay, now I'm going to show you how to edit, because of course you created lots of lines, lots of polygons, points, but maybe you are not happy with some of them. Maybe you did something wrong, you want to move stuff, and so on. So let me just categorize my points, for example, by creator type, just to show you again, and so on. This is the same base map. I have created something similar to Luca. For example, you see I have put some points here, one is here, one is here, and one is here. I'm not happy with the position with any of these, and I want to move them. So how to do that? So as before, to do this, we need to go select the entities we want this time to modify, and we will go again to the toggle editing button. So to act anything on your vector files, either creating new ones or modifying them, you have to toggle the editing on. As before, if I place a new point like this, here, for example, or here, I can create a bowl-shaped crater. I have created different fields, but it's okay. It's crater 4, and so on. But I'm not happy with this position. So you see that next to the create point button, there is another button. This button here, it's called vertex tool. And what it does, if you enable it, it changes your cursor. And if you hover on the mouse on top of the entities, on the point entities, they are highlighted like this. If I want to move this entity, for example, to change its position, I hover the mouse, I left click, it becomes a red cross, and you see I can move this cross and change its position. For example, I want to put it here. Then I click again with the left button of my mouse, and the position of the point has changed. This can be done with every entity, point entity inside this layer, if you have toggled on the editing. Okay, so hover the mouse when this option is toggled on, hover the mouse, left click, then you move your mouse, and then left click again. So let's say we want to move not just one point by one point, but we want to create something more. And to do that, I need to create another toolbar, which is called Advanced Editing Toolbar. So as Luca said before, to add new toolbars, you right click with your mouse somewhere where there you have empty space. And we go here and we toggle this option on. We toggle on Advanced Editing. And here another toolbar appears. So here you have your toggle on editing, create features, modify point position. And here you have other options. You see this one, it's very similar to the create new feature, but instead of this, let's say, pop-up icon, it has an arrow. And if you click here, you have two options. You can move features or copy and move features. So let's say I want to move a feature. I simply click and then click again. But if I want to copy and move a feature, I select this option, then I hover the mouse on top of the feature that needs before to be selected. And I don't see the selection. It's covered by my Zoom interface. Sorry for that. I need to move it. Okay. If I want to edit in an advanced way these features, I have to select them with this selection button that, by the way, enables you to select by square, by creating a polygon, okay, to select features, or with freehand, just left click, then move your mouse, and then right click, and then you have selected your feature. So you see now I have selected them, they are marked with a cross and they are becoming yellow. And now I can, for example, copy and move features, okay? So I simply click, sorry, I need to select them. And then I click on this button. I have a cursor becoming a cross. I click somewhere just around this feature, and then you see I can move them. They are being duplicated. If I left click again, I have created a new version of these features. I can create as many as I want. When I click with the right button, it is done. If I click with the left button, I enable again the duplication of these features. If I left click again, they are released. If I right click, I stop the editing. If I don't want to move them and copy them, but just to move them, I toggle this option. I simply left click around. This time, you see, I can still move them, but if I left click again, they change position. They are not duplicated. So these are very, very useful tools.
Just 5 minutes left.
Yes. So let's save it. Let's go for editing lines. The principle is similar. We need to select the lines. We can categorize the lines, for example, by say type of contact certainty. If I certain or infer, this time they're all certain. I can style them. I can put them in red and change the thickness. I'm doing that because you can see it better. So you see, I have marked different contacts. I have marked the border of this crater, but I don't like because I've seen from further interpretation that my interpretation is wrong. So how to do that? I select the line, toggle on the edit option. I don't click on create new feature, but again, in this modify feature button. And as before, if I hover my mouse on top of my geometries, if I move it on top of the vertices are highlighted. If I hover it on top of the lines are highlighted. And as before, if I want to move a vertex, I simply left click, move my mouse, left click again, and it changes the position of the vertex. You see? What if I need to create another vertex inside the geometry? I simply hover on top of the segment connecting to nodes. I left click, I can move it. And if I click on the cross just in the middle, I can create a new vertex. You see, I have created a new vertex. So you can do three things. You can move the nodes you can hover on the segment, and if you click on the segment, you can move the entire segment. And if you click in the middle and the cross appears, you can add a new node, and you can basically add new nodes and complicate the geometry as much as you want. As before, you can move and duplicate, and so on. I want to show you just another thing, the snapping. So you see here, I have created two lines that are not connected. How to make them connect correctly? Again, I right click on my empty toolbars, and I go here and I enable the snapping toolbar. It has this icon here with a magnet, and it does what you're supposed to do. If you enable it, toggles on these features, and then you can snap, so attach different parts of your geometries one to another. So what it does, if I modify it and I go close to the other edge, you see that it snaps on the vertex or on the segment. So when it becomes pink, it snaps like it's magnetized, and then I can left click again, and they are connected, and you can see it by this green cross. This can be also done if I want to create a new feature. I simply toggle this button on, and if I create a new feature, a new line with this button toggled on, you see the tip of my line. If I move close to a segment, it is snapped to a segment. You see? And then I can click and create a new feature. Same thing for polygons. By the way, you can also cut the lines with this button here. What you simply do is toggle this button with the scissors, and you can left click, you create a line crossing a segment, for example, and then you can right click, then you can do it again, for example, here, right click, and if you select the features, you see I have cut my geometry. And then I can remove part of the geometry by hitting cancel button, you see? If I'm not happy with what I've done, of course, as in any program, there is the go backward button, or go forward if I want to undo or redo my modifications. This can be undone or redone until you save them. If I save it after my modifications, I can't do it anymore. And if I re-enable it, this is lost. So be sure that after your modification, you save, but be also aware that if you save, all your modifications are lost. You can also edit polygons pretty quickly. I want to edit my polygon here. So I select polygons, I toggle on the editing, same button, and again, I can move vertices, add new vertices, hover and shift the position of a segment, add new vertices, and so on. But another nice thing you can do is to basically erode or add new parts of a polygon. So in this bottom here toolbar, there is this button here with this shape, with this diamond thing. If you click it, if you start from inside the polygon, you left click and you add a new portion of the polygon, and then you right click inside the same polygon, what it does is to create a new part of the polygon. You basically need to start from inside, go outside if you want to expand it, and be sure to right click inside the polygon again. The same thing applies in the other way around. So if I want to erode the polygon, I click from outside, I go inside, and then I right click on the outside, and it cuts portion of the polygon. And as before, with this button, I can simply cut in half a polygon, you see? I can cut in half, I can cut again, and with my selection button, then I can select it and I can delete it. So it's pretty simple and straightforward. Very last, no, I think I need to stop. Of course, the snapping button can be enabled or disabled, whether you are adding new features or editing features. Be sure to save, and then we are done. Now we have a seminar by Trent here from the United States Geological Survey. And after that, you will see how to use Poly plugins for QGIS, how to install them, and how to use the Mappy plugin for mapping very effectively within the school without losing time doing all the stuff. Basically, it's very useful, but Mappy is doing something even cooler. Thank you for listening, and I leave the stage to Trent.